So then, how can we construct the confidence intervals? There are two methods. One is by inverting the acceptance region of the test, and second method is using the pivotal quantities. So let me talk about first the method one, by inverting the acceptance region of the test. So in the hypothesis testing, we have learned that there is a acceptance region and there's rejection region. So the acceptance region is that the 1 minus, is the complement of the rejection region, which means that we are so the acceptance regions that we accept the null hypothesis theta equal to theta 0. So if we we can invert this acceptance region and so that we can obtain this confidence interval. So the theorem So let A theta 0 be the acceptance region of level alpha test of H0 theta equal to theta 0, and then we define a set Cx, which is the function of theta where the A theta contains the sample x, and then the random set Cx is 1 minus alpha confidence set. So is the theorem first part of the theorem 9.2.2 says that if we invert the test, then we can get the confidence set. And then is the reverse is true? My answer is yes. So if we define the 1 minus alpha confidence set, and then for any theta 0, we define acceptance region of the test for hypothesis the H0 is theta equal theta 0 by 8 theta 0, then the test has level alpha. So what this theorem implies is that there is a one-to-one correspondence between a test and confidence set. So proof. So 1. So we consider the x does not belong to A theta 0, which means that A is not in the acceptance region, x is not in acceptance region. That means that x belongs to the rejection region, which means that we consider the probability that reject H0, and then since this is a level alpha test, so that is the less than or equal to alpha, and then this means that probability that the x belongs the acceptance region is greater or equal to 1 minus alpha, then we can change theta 0 to theta because theta 0 is arbitrary. So the probability that the theta belongs to Cx, now you can see that the Cx is the collection of the theta values such that the 8 theta contains the sample, the x. This is equal to probability of the x belongs to 8 theta which is the greater than 1 minus alpha. So by definition of the 1 minus alpha confidence set, so it is the 1 minus alpha confidence set. I mean the Cx is the 1 minus alpha confidence set. probability under theta 0, the rejected H0 is the probability that the X is not in acceptance region. This is the 1 minus the probability that X belongs to the acceptance region. Then we know that by definition of the 1 minus of confidence set, so we have this result. This is so we can get the level alpha test. So now I use here the expression the confidence set because the set is more of it's a broader concept than the interval. So we have this result, and then you can see that we have expression A theta 0 and then Cx. So there is a difference between two. So the A theta 0 is set in the sample space, and the Cx is set in the parameter space. So you can see that, for example, A theta 0, it is the sample X such that so I'm just giving an example of the two-sided confidence interval for Z test. So A theta 0 is the talking about the sample. So sample such that the X bar is between theta 0 minus GR power 2 times sigma divided by square root of n, and theta 0 plus GR power divided by 2 times sigma divided by square root of n. So A theta is talking about the sample in this interval. So it's about the sample, so it's a setup in the sample space. So here the parameter is a fixed. However, the Cx So Cx is about the theta, so it can be expressed as the theta is between the x bar minus c alpha divided by 2 sigma divided by n, and c x bar plus c alpha divided by 2 sigma divided by n. So here our sample is the fixed, but we are changing the theta. So method 1. So I'm going to talk about inverting the test statistic. So there is no guarantee that the confidence set obtained by inverting a test will be an interval, but quite often So to obtain the two-sided confidence interval, 1 minus alpha two-sided confidence interval, we invert the acceptance region of the level alpha test for theta equal theta 0 versus the theta is not equal theta 0, which is the two-sided test. So we invert the acceptance region of the two-sided test to get the two-sided confidence interval. So to obtain 1 minus alpha confidence interval, when we have lower bound, the upper bound is infinity, we invert the acceptance of reasonable level alpha test for h0, theta equal to theta 0 versus the h1 is theta is greater than theta 0. Finally, so to obtain the 1 minus alpha confidence interval, the lower bound is minus infinity and we have upper bound ux. Then we invert the acceptance region of the level alpha test. For h0 is theta equal to theta 0 versus the h1 is theta is less than the theta 0.